Good morning, good afternoon, I guess at this point. We are Lucas and Michael, or McAtee, and we are here to talk to you about Microsoft Windows shares and how we use them on our internal pens. So briefly about us, my name is Lucas. I am a manager for a company called Crowe Horwath, which is an accounting and consulting firm, and we work as part of the security and privacy group inside that. I'm a manager, in quotes, because I don't really manage a lot. And when I do, I'm probably bad at it. But I'm also a pen tester and ultimately a code monkey. I write a lot of scripts, a lot of tools, and other things.
Yep, and my name is Michael McAtee, and I'm a senior consultant at Crowe as well. Pen tester and was a sysadmin before that. So that's why this talk's on the Windows shares. And couldn't think of anything funny, so we just left a placeholder for something funny. Insert your own joke there. And then ways to contact us, just the obligatory. Go to this page or tweet us or whatever you want.
Oh.
Okay, so quick overview of what we're going to talk about. We're going to start off with a little bit of a refresher on SMB and CIFS and Microsoft Windows shares, so everybody kind of has the same base, understands the problem we were running into, and why we built this tool, and why we use this as probably one of our primary go-to methodologies in pen testing now. Then we'll dive kind of deep into how permissions in Windows shares actually work. Share permissions versus NTFS, how those are stored, what they mean, what we're pulling, what the tool's actually putting out, all that nitty-gritty stuff. The problem we found when we started using this day to day and the troubles with other tools that are great at what they do but just didn't do what we needed them to do. And then we'll kind of detail our methodology, what we look for, why we look at shares, things like that. And then tools, hopefully a demo, maybe a video instead. We'll see how it goes.
See if our sacrifices to the demo gods were successful.
So, start off with CIFS. CIFS, Common Internet File System. This was Microsoft's nice and pretty name that they put on SMB when they wanted to make it a standard. They went ahead and sent a nice draft off to standardize it and then let it expire, never made any of the changes. So it is almost open and almost a standard, but it's what everything is published against. So there's not a great defined, here's how you implement CIFS. It's more, here's how you get close enough that you can get a file share and figure out the bugs as you go along. Since Windows 3.1, Microsoft has had networking built into Windows and some kind of SMB. SMB was originally developed at IBM, and then Microsoft kind of took it and ran with it, and pretty much every major version of Windows with the release brings a new version of SMB. And especially here in the past few years with Windows 7 and then Windows 8, Microsoft has really pushed hard on this as their core technology, not just for file shares and things of that nature, but they're actually backing their Hyper-V clusters with it, recommending it over using something like iSCSI or NFS, and have put a lot of effort into cleaning up the performance. They actually, if you look at the specification from 1 to 2, they dropped the number of commands from like over 100 to about 19. So really cleaning up the spec, trying to make it better, and we'll get to Samba a little bit later, and they've kind of started to follow that process just a little bit behind. So share types. Probably everyone has seen these before. If you see a share with a $1 at the end, unless somebody's done something a little funny, that typically means it's hidden, doesn't show up unless you go looking for it or has a tool that pulls it specifically. The other share that you'll see everywhere is IPC $. It's inter-process communication. This actually is where all SMB sessions start. And so SMB is used for a couple things, not just file shares, but also printer sharing. You can also share serial ports, apparently, over it. And Microsoft has all kinds of random calls. IPC is how you pull where RPC endpoints are in a Windows environment. So if you have a bunch of SQL Server instances running on a Microsoft machine, you're going to connect through SMB to IPC $. You're going to make some calls against that, and it's going to give you the information you need to go connect to that. So all that automatic finding fun stuff that happens all goes through IPC $. So that's the starting point of any Microsoft Windows SMB connection. Next one here is admin $. This is a special share that is kind of a core part of our methodology, so we'll get to those specifics, but this is on by default in every version of Windows, and it takes you to Windows System 32. It's supposed to just be an admin share. Some tools use it. It's, for instance, PSExec uses this. So if you use PSExec and you upload an executable, it's going to drop that executable into this admin $. Share. You can open up Wireshark and actually see it map and drop the file. Along that same line, considered admin shares, C dollar, D dollar, E dollar, however many drives you have will pop up, and those are just administrative shares that are locked down by default to just local administrators, and they will allow you to gain access to those various drives. Here until recently, you couldn't turn those off. You could disable them, and then when you rebooted, they'd come right back. Microsoft has released a hot fix, though, that you can use to fully disable them. So, nice fix for workstations if you know that they shouldn't be sharing anything, you don't want anybody to set something up that maybe you didn't know about. You can go ahead and run this on all your workstations and no more file sharing.
Just, make sure you're not using them.
Yeah. Tools you would not expect to use them.
So, if we start looking at a little bit more of the detail of share permissions, there's actually a few things that we wanted to talk about. Now, the first here is what's called a DACL, or Discretionary Access Control List. It's a bit of a mouthful, but basically this is how Microsoft stores permissions for everything. It's part of what's called the SDDL, and basically it keeps permissions for a lot of random stuff. Shares, files, obviously, services, processes, threads, all have DACLs that can be associated with them. I was actually surprised when we started digging into this, all of the places that these were applied. And basically the way that they're put together is, as you can see here, it's just it's actually stored, obviously, when you print it, you get a string like this. And it is just key, colon, value, comma separated. And you will see a lot of different things. In this case, the example is for a share, and you will find the revision as well as basically the owner, the group that owns it, as well as the ACL. This is actually the DACL as part of this. And what really all this comes down to is all the stuff you can set in the security tab. It's all this, just condensed down into computer. So inside the DACL we have the ACL, and each ACL has a single line called an ACE, or an Access Control Entity. And what an ACE has is it has the principal. Now this is actually stored as a SID, but in our case we always reverse those because who wants to read SIDs all day? And so it's the SID, and then we have a colon, and then the first number basically says is it allow or deny. So in this case it's an allow because it's a 0. This is what most people use. I feel like with most of what we do, we almost always see allows. But sometimes we do see a deny. It would be a 1. The second number after the slash is basically flags that are on this ACE. The ones you see the most and the ones that are really only relevant to what we're doing here are we inheriting this from above? Are we forcing a propagation down? Those sort of settings. And then finally, we have the access mask. And the access mask is a 32-bit bit mask that we use for all of the various settings. Now what's important is the way this works is unified across all of the different types of objects that Microsoft keeps permissions for. The individual items within may change a little bit, but not necessarily beyond the specification. So, let's talk a little bit about files and shares specifically. I'm sure as most of you know, shares have permissions, files have permissions. And in the end, it takes whatever the lowest privilege is that you've been given. So if you have a share that's read-only, but your NTFS permissions give you full control, you're only going to be able to read from it. Shares, the permissions are pretty limited. They're limited to what we would see in the old DOS days. We can read, we can change, we can execute, but you basically see read, change, and full control. On NTFS, we have a lot more granularity that we can put in. And these are the main ones, probably pretty self-explanatory on them all. We weren't going to spend a whole lot of time on it. But if you look at special permissions, there is a lot. And with each new version of Windows, you get even more. And I mean, there's just a lot of stuff that they store.
Yeah, how many people have ever opened up the security tab and what's the special thing? And I'm not going to mess with it right now. When you check that, all these get enabled by default. So that's why when you hit full control and that box is the only one that gets added from having read and write. It's all of these that it's adding.
Yeah, so be aware. Now, in addition to NTFS permissions, there are also attributes that can be set. These are attributes from the old days of DOS. They are still there, and basically the two that we really care about are read-only and hidden. But there are several others. And actually, sometimes you will find some interesting things with archive because you can pull things back and do some other stuff. If people have changed versions, you may be able to do some stuff with security controls. But in general, read-only and hidden are the ones we care about. Shares and directories, as well as files, can all be flagged as this. So although he mentioned earlier you can have the $ after a share, that's typically how most people make it hidden. You can actually flag it, and although it gets a little weird when you're looking at it in Explorer, it will actually cause it to be hidden. Same thing with read-only. Even if you have the permissions set, but you've got the read-only flag set, it's still only going to be read-only. So it's kind of a weird interaction between old DOS days and new days and keeping stuff backwards compatible that you have these permissions. Now, in addition to the DOS mode, recently they've also started adding in extended attributes, or EAs, and these are things that are entirely custom. They can be added by different programs, extensions. So we've actually seen backup programs will use it to flag, when they've last passed this, handle incrementals. Some antivirus programs will add stuff. Lots of things can. Now, in the end, for us as pen testers, it's not as no problem. It's not as big of a deal. These are things we're seeing in user space. We haven't seen any vulnerabilities or anything that we've done with it, but there's probably some potential there. So it would be awesome if someone dove into that and took a look.
Especially going forward as Microsoft starts to use them more. And so.
Yeah, a lot of internal tools and other things are using it. So if we get into the ultimate nitty-gritty of DACLs and permissions, this is what an access mask looks like. As I mentioned before, it's 32 bits. And in the end, it all comes down to this. So in the center, in the green, you will actually see what are the global or standard access rights. And these are available on every single type of object. So the rights that you have are pretty generic. The first one is synchronize. And basically what synchronize says is, are we allowed to access this object synchronously or asynchronously? Does my thread have to hold or not? It's not one we've ever even worried about. From a file and directory perspective, you are pretty much always allowed to do it asynchronously, otherwise the system would break. The next one, I'm going to have to. Oh yeah. Okay, so the next one is basically, are we allowed to write the owner? Can I change the owner of this object? Pretty straightforward. We also have, can I write the DAC? And that is, can I write the DACL? Are we allowed to change the access permissions and alter the ACL? So it's a little meta in that the ACL includes the permission on can someone modify itself. We also have, can I write extended attributes, and can I read read and write attributes. So this is not extended attributes. This is the attributes we were talking about before, the DOS mode ones. So this is hidden, read only, that sort of thing. And are we allowed to modify them? And then finally, the most self-explanatory one out there, can we delete the object? So those green ones are always there. So the little further to the left in black is one that also is global. It's always available, and it basically says, can I access the system access mask? Now this is one that you don't see very often, but basically there are DACLs and then there are SACLs, SACLs. And what a SACL is the name is a little bit of a misnomer in my mind in that it basically says, am I going to audit when this object is accessed? Am I going to audit when something happens? So what this really does is it drives a lot of stuff that goes into the Windows event log, that it goes into other extended logs that you may have or may turn on. So it's not one that we see very often. It's not one that we really worry about from our testing perspective, but it is certainly one just to keep in mind. Finally, if you look on the right, no, not you. If you look on the right in the orange, okay, so if you look on the right in the orange, these are the ones that are specific to files and directories. This is where you'll see a little bit more of the stuff you would expect to see from a permissions perspective. Can I read and write extended attributes? Can I delete the file, read the file? Can I write new files? The ones you see listed up here are for files. So the names are different for directories. Technically the object type is different, but...
Can you do a shaft?
Of course.
New speakers, round of applause for new speakers.
And this is where the presentation went downhill.
Give me about 10 minutes and then we'll see.
question is, can you continue?
I'm a professional.
Okay, so in the orange, the ones that you see up here are what you'd expect. As I said, with files, those are the names you see listed here. With directories, well, honestly, on a file, if it says, can I write to the file, the permission on the directory says, can I create a file? So they map. They are pretty standard. In fact, in some of the stuff we've done, we don't even bother keeping the two names. But just in case you ever decide to go look at this in Microsoft's documentation, A, I'm sorry, and B, note that the names will be different.
It is extensive documentation.
Yeah.
I made him do it.
Go back, there's still,
Oh, yeah, sorry.
you skipped ahead. So then finally, the four blue ones on the right are kind of meta permissions. Basically, these are the ones you would expect to see, right? You have write, you have read, you have full control, you have change. And so really, if someone sets these, it sets all the other flags. They are assumed, though, but typically almost every program will implement it. So if you pick the read flag at bit, I think 30 or 31.
31's read.
If you pick the read one, technically you have all the read permissions. It doesn't even bother to look at the rest of them. But pretty much every program on the planet will go ahead and set the fact that you can read files, list directories. It sets asynchronous, it sets read extended attributes and read attributes, that sort of thing, execute file. So those are there, also important to note. And this was a lot of time spent figuring out what the right document was. And then when we found it, it was actually quite easy.
Okay, so we had to go relearn some of that and learn for the first time a lot of it because of a problem. So share scanning, we keep finding, is kind of a pen tester's best friend. One, it's where all the information is typically. So you're going to go after it for that. Find somebody's password.txt and things like that. Windows images, pull some creds out of them, all that fun stuff. But there's other stuff you can do too. But what we found was the tools weren't really built to do everything that we needed them to do. And there were some problems with some of the tools that existed because they had been built to do this or that, and so they didn't take into consideration some other things. So some of those problems we ran into is some of the tools have immature or just incomplete authentication libraries. So while they'll support LM and NTLM v1, they may not support v2. Or maybe they don't appropriately handle NTLM SSP, the security provider process. So even though their library may support v2, they never get prompted for v2. Like it won't ever just kick in. And we ran into this with a couple tools. It includes, oftentimes these tools aren't share scanning tools. What they are is a port scanner, a vulnerability scanner, a generalized security framework, and we'll go through some of these tools later, but they do other things. So, Nmap scans for open ports before it does any of its scripting stuff. Nessus does some checks to see what kind of system it's testing so that if you've checked don't scan printers and all that stuff, it knows it's not a printer. Just a lot of traffic that isn't share traffic and oftentimes can tip somebody off that what's going on in the network is something weird, something malicious, and we wanted it to be as clean and all legitimate traffic, so it's much harder to detect.
We don't like getting caught.
No. The other thing is slow. Some of the tools just wrap other existing tools like smbclient. Some are written in scripting languages. The whole libraries are, which is a crazy feat. Kudos to the people who wrote those. But they're slower, right? I mean, how many times have you gone to a Windows file share and it's slow and that's all written in C and been optimized for years by Microsoft? So, somebody implementing that in a scripting language, it's just slow. And we needed it to be fast. And finally, almost none of the tools would recurse down a tree. So if you have a folder structure that has 120,000 objects, files, and directories, and all that stuff, these tools wouldn't go down and find those for you. They'd typically give you the share permissions. Maybe they'd give you the share permissions plus try to upload a file to tell you if you had write access. But they just didn't give us all the information we really wanted to have. So here's some of the reasons that we share scan. First one is obvious. This is why everybody looks at shares. Sensitive data, right? You look for the HR share. Check out the salary, the person who hired you. What's he or she making? What's the IT person who keeps yelling at you every morning that you broke this or broke that? What's he making? All that fun stuff. You look for IT shares. The Windows administrator has that big installer package for SCCM, and he downloaded it. Now he's got to get it to the server he's going to install it on, you know, he's been working 12 hours that day, so he just opens a share in his documents, right? He just opens it up or just dumps it in an application share somewhere, and then now this has become a dumping ground, and just all his stuff is in there. Scripts that have passwords, all that fun stuff.
All of them come from maintenance windows at 2 a.m.
Yes, exactly. Backups, we see this all the time, is there'll be a backup folder that a permission was opened up, so tool XYZ can go grab a virtual machine and make a backup or do a backup of a specific share, or you know, all these different things, and they just dump it to a writable share on some big piece of storage, and no one ever goes and locks down those permissions. And we have gotten control of several admin passwords just by grabbing a backup and dumping that backup out in a Windows image file or vRanger or something like that, and pulling local admin creds, pulling sometimes cache credentials, you know, anything you could pull off the hard drive of the system, you could pull off these backup images typically. And finally, one of the more fun ones is we find source code a lot in shares. Either source code for vendor tools or stuff created by those tools. One of the ones that was interesting is we found a very large help desk system that lets you attach and track changes and tickets and all this. By default, when you set it up, it creates a share that you can map and everyone has access to that contains all of those attachments. So if your change control system, if you're putting, here's our original router config and here's the change we're going to make, and it's a non-redacted configuration because it's internal, we were able to get those. And we actually did dump all kinds of, we dumped configurations for switches and routers, firewall configurations.
New passwords.
Passwords, yeah, new passwords that got set. Audits of their weak passwords for like service accounts. It's like, we know we have these eight weak passwords, but we can't change them. And here they are. So a ton of stuff that you can find that's just fun. But that's only a portion of what we do. And typically it's what we do after we've taken over a network, or if the goal is not to just take over the network. This is the other stuff we go do. Go find weaknesses.
Right,
what we use it for first.
Oh no, I was just going to say DOM admin is nice, but man, you come to a bank with a list of every account number, they listen.
So the first thing we always use it for is just system fingerprinting. Once you have authentication and you pull a list of Windows systems either through port scanning or listening to network traffic, what kind of system is it out there? Is it a domain controller? Does anybody know 2 shares that are on every domain controller? Anybody? Sysvol net logon. You see those, you're looking at a domain controller. So that tells you exactly what that system is. If you see WDS, Windows Deployment Services, has a set of default shares that it kicks in. I think deployment share is that one.
I don't remember off the top of my head.
WSES, SCCM have default shares that they put enable. If you want to find
older versions of IIS.
If you want to find the HR system or the IT system, look for the IT share on one server somewhere or the HR share on one server somewhere. You want to see where everybody's files are. Usually it's profiles or users on some big piece of storage somewhere that has everybody's stuff. And sometimes those permissions aren't right. So it can tell you a ton about what you're actually looking at.
And as a side note, if you're trying to be really stealthy and you can't port scan, you can't do anything to try and actively identify Windows hosts, use something like NBTenum, userinfo, winfo, and go to the domain computers group. And although they are accounts, if you just remove the dollar from the end of it, that'll give you the pretty much a full list of every workstation and server in the domain. And it's not going to get caught.
Yeah, you're not going to get caught. The only problem with that is if they don't clean their A&D environment, which no one does, you'll have about half of them, were disabled 3 years ago and don't exist, but you can clean that up too.
Okay, so beyond that, and beyond what is the obvious of shares, we have also found a couple of unique uses for us. And we were actually talking earlier, it's probably about half of our attack vector to domain admin on all of our pen tests involve these days. It'll probably start to change, but the first one, the big one is the local administrator password reused? So you remember the admin share that we talked about. If you've, popped a box, you've got one workstation, let's say it's through, social engineering, or I don't know, you've got a share with WDS images or something like that, and you've got a local admin password. Next question is, well, where is it reused? Well, you can do a lot of different things to find that, right? There are a lot of different tools. Hydra will do it, Medusa will do it. But that's going to look like a logon attempt. It may get you caught. It may not rise above the background radiation of the network. So it's really simple. Try and mount admin dollar on every workstation with that account. If it works, bam, you know where it's reused. And so we're on pens all the time where we've got 1,000, 2,000 workstations. And what we will find is that sometimes clients are pretty good. They'll maybe put IT with their own local administrator password, maybe HR, and then everybody else has the same one. So at that point, I'm effectively a domain. If I control 1,900 of your 2,000 workstations, it's only a matter of time.
A domain admin will log in at some point. Just got to be patient.
Somewhere we can steal a ticket. The other piece that you can actually help out with is you can start to learn, is it renamed in the same place everywhere? And yes, admin what admin is one that we found.
That is my favorite local administrator renaming. Everyone should use this. Admin what admin.
But my favorite is still that we've had several clients recently who, per our recommendations, they've renamed the admin account or they've disabled it, which is good. Disabling the admin account prevents a lot of lateral expansion of your access. And then what they'll do is then they'll go and they'll turn around and create 3 new ones. One for the help desk, one for the antivirus updates, and one for patching. And they're all local admins. And you kind of give them a blank stare being like, okay, did you think this through? So we also find that all the time where there's local accounts that are reused. Sometimes they're local users, and we can work with that, but more often than not, they're local admins, and that's just bad. Also, we will also find where if we get one user's set of credentials. Now, we'll do this through Responder, if you guys know about that, LLM&R. If not, it's really cool. I highly suggest you look into it. We will get a credential from that. Maybe we'll manage to crack it. Maybe we'll get some local cached creds through McAtees that have come to us. Sadly, they're a regular domain user. They're no one important. But you will often find, again, you've got 2,000 workstations. How often do you think the admins have gone through every single workstation and made sure that people aren't a local admin on it? How can you make sure that that workstation hasn't been upgraded from Windows NT and still has the everyone group in the local administrators? Well, it turns out pretty often that's the case. So I would say consistently we will find 1 or 2 workstations or maybe a server where everyone is a local admin, where domain users has been put in that group. And we're now immediately escalated up. Now all we got to do is get an admin or DOM admin to log into that or do something to get credentials. Half the time they're already in there. So again, what we'll do here is as soon as we get creds, hashes, passwords, whatever, we will start scanning for the admin dollar share across all of these systems to see where we have admin access. And then it's just one more step, one chink through that.
So before we started writing this tool, these are the tools, with the exception of ShareEnum, that we kind of had access to. Nmap obviously has the NSE script. They've been working on the authentication piece. We had some trouble with that. But besides that, it's fast. It gives you the default permissions for that share. It tries to upload a file to see if you can write to it, lets you know if you can read to it, prints it out in a nice format that you can then go through and parse. But it's a port scanner. It does port scanning beforehand. It does other checks. It checks for random ports that aren't related to Windows traffic. So it's kind of easy just to look at traffic and, is a port scan being done? Yes. Okay, this probably is not an actual share mounting. Sysinternal ShareEnum. Very hard for a pen tester to use this. It is kind of finicky. Now, if you are a Windows admin and you're wanting to review your own share permissions and kind of look at things in mass, it's a great tool. But it's kind of hard for us to use this at scale if we're trying to look at 2,000 Windows systems and we don't necessarily have a domain machine to run it on.
Yeah, it won't let you put in creds.
And then Nessus. Nessus actually, our biggest complaint there just used to be that it was slow, but it's gotten a lot faster here in probably about the last year. It will go to some level of recursion. It's not really clear how far it will go down, but it will pull some files and folders and tell you the permissions there. It will tell you if you have write permission. Again, it tries to upload a file to verify that you have write permission. But it's a vulnerability scanner, so it checks if it's a printer. It checks if it has certain ports open. It checks if it's a Novell system. So it's pretty obvious that something that's not just mounting a Windows share is going on.
And the plugin will actually look for several common share names, so it's also easy to identify because it'll try invalid shares just to see if they exist.
Metasploit has a couple different modules that we used to use. This was pretty much what we used to use for this before we wrote ShareEnum, and that you can just try logons, which is just failed logon attempts if you don't do it right, or successful logon attempts with no activity. Again, looks a little suspicious across maybe 1,000 Windows workstations. It also has the ability to pull shares. Again, it doesn't really recurse. It kind of gives you that high level, what access do you have to the share. It'll try to mount or try to upload a file to see if you have write permissions. And it also used to be pretty slow. Now they've threaded theirs because they rewrote their SMB libraries in Ruby, which is insane. But so it can be very fast. ShareEnum is one that we found actually while we were writing this tool, and it runs on .NET 4.5, I believe. So a little finicky to get it running, but once it does, you can provide it creds. It pulls a lot of the information we do. The only thing it does that kind of bothered us is if it gets a failed access attempt, it will try a couple times just to be sure it really got the failed access. And again, that just looks malicious. If you're looking at those logs, why were there 4 failed logins in a row? It'll try to anonymously bind whether you gave it creds or not. So it's just some additional stuff it's doing to really give you a thorough review of that share, which is not necessarily what we want. We want to glean some information from it while not being too noisy. And then finally, you can always use Explorer, NetUse, and smbclient. If you haven't used smbclient, if you've ever used a command line FTP client, that is smbclient, which is for Windows shares. So you can list the shares, you can connect to them, and you can do mget, input. It doesn't really tell you the permissions. If you don't have permission, it yells at you. If you do have permissions, it'll download or list the file or whatever it is. That will take forever.
Okay, so these are a lot of the tools that we've used to use. They were great tools, but they didn't meet the need that we had, which was to do it in bulk without sending a lot of traffic. So we thought to ourselves, well, we can probably be like a lot of other hackers and just do it ourselves. And we sat and thought, but we're not crazy. We don't want to implement, SMB in Ruby or Perl. And at the time, that really wasn't there. But there actually is a group of people that have done this already, and they've done a pretty damn good job at it, and that's Samba. They have libraries that they use. I mean, Samba 4 can emulate a domain controller. It does a pretty good job. I actually have one client that manages their entire environment through Samba. They're crazy, but smart. And so basically what we decided is we're going to use the same libraries that smbclient does. There's a nice abstraction library that they have called libsmbclient, which provides a lot of functions that you can use to call all of these different things. And it's a lot faster. They have compiled IDLs that allow them to make RPC calls quickly. It's much more native, and it's written in C, so in general it's going to be just faster than using an interpreted language. The other really nice benefit here is the Samba team works really hard to make sure that they can support all of the same stuff that Microsoft does. Now obviously they lag a little behind because they have to implement specs after Microsoft comes out with them, and it's open source, so they don't have the army of programmers that Microsoft does. But it supports all of the cool stuff that we need. NTLM-v2, SSP. Our tool doesn't do it, but if we really wanted it to, it would actually support Kerberos auth. If any of you have all Kerberos authentication, good for you. We're not implementing that until we find someone that does. So it made this a lot easier for us.
And Samba is everywhere, by the way. Almost every printer. You will find the Samba code in various versions on almost every device out there. So it has been battle tested and optimized by everybody who's ever tried to do anything with a Windows share.
Which, a cool little side note, for those of you that didn't hear, there was a remote exploitation and command injection vulnerability in the NetBIOS name daemon for Samba that was released this week. And so because this is in every printer and basically the entire existing corporate Internet of Things, it might be interesting to take a look at. So for what we do, we gather the DACLs, we parse the ACEs, we give you a nice CSV so that you can go to your spreadsheet of choice and filter everything out. We do also, we'll recursively go as deep as you want. So we have actually pulled every permission from a file server that had over 500,000 objects on it. It took about 30 minutes, and it was a gigantic CSV file. Excel complained. But we also support anonymous. We can use regular creds, and actually we do support pass the hash, although there's a little of a caveat there. So,
Demo.
we do have a demo.
At least a video, hopefully a demo.
And hopefully this is easy to read. We always hate it when
always see
people
that.
get...
Is it good? Is it up there? I can't see
Good.
it.
Can everybody see? All right, good. We always hate it when people throw up a terminal and it's 12-point font, black background on green.
Okay. So, just give you the nice little print here. Again, we have a nice menu that tells you all the flags. You can also see that on the GitHub page since we're making it big so you can actually see what we're typing. It's not as nicely formatted. But so the first one is just enumerating shares. So we have a set of creds. We have a list, one IP or host name per line file of the targets we want. Actually, I can cap that. So you'll see.
We have a few hosts in a test lab in our
Yep.
labs.
Few hosts we want to see. What do these creds have access to? What shares are out there? So we do ShareEnum. We give it a user. You can do without the domain, but I'll do the domain. Bash, you got to escape. That has bitten us a couple times.
Make sure you type it right. You lock out accounts.
Yeah. We have locked out accounts too. The password, super strong password. We give it an output file, which is just a CSV, and then we provide it the targets. So in this case, targets.txt. We give that a run. You'll see nice, pretty colors.
It pauses too to make sure you typed in the password right because we locked out a whole lot of accounts once.
So and you'll see it goes through and it's telling you what it is actually getting. So if it had some errors because you didn't have access, it tells you that. If it pulled some objects, pulled some information, it tells you that. And we even give you a nice little color so you can just glance to see if you're getting a bunch of red X's or if you're actually getting some data back. And so we will show you what that looks like here.
And so while he's pulling that up, for each of these demos, we're also going to talk about some mitigation steps that if you're on the other side of the house, right? We like breaking into things. Both of us used to be admins in the past, so we understand. We don't want to just come in, break everything, and then leave and say, here's how you suck. So we prefer to at least help you along the way. So let's talk about this one. This is obviously very difficult. You need shares enabled. But something that actually one of our clients did, it took us by surprise because they didn't do it out of this, is they actually logged whenever someone used $C or admin dollar. And basically if they saw more than like 5 of them in a time period to their SIEM product, they generated an alert. That stopped us real quick. That was tough.
And so see they have this Excel file open here and we provide you a lot of information, some headers. The user you ran the account with, so if you're maybe combining these into a lot so that you kind of just have this analysis, you can tell what user you ran it with, the host, what the share name is, what type it is. So right now it's just going to show file shares. When we show recursion in a minute, you'll see it'll say if it's a directory or a file. And then we actually pull the DACLs we talked about. So you'll see here, authenticated users has read extended attributes, and execute. And you can actually go through and filter this. So if we want to look for all those admins we talked about, now we can tell where this user has local administrator access. So if this was a pen test, we would then go to the system and we'd pull the local administrator creds, which we've done for you. If I can use screens. So again, the same user account, we have provided it the credential here, and this is the format, the same one that Metasploit uses, which is the LM hash : the NTLM hash. So you just provided that.
You can copy it straight out of pwdump. Just make sure pwdump will put no space password. So make sure you fix that.
So we'll let that run, and you'll see we're pulling results again for each of the hosts with the hash there. And if we look at that output, again, we can filter this up. And again, we just ran it with that same user, so still just this one account. But if we had run it with the actual local administrator, then we'd see that admin share everywhere. And actually, I tend to, if we're running a big host, I'll have grep open just looking for admin dollar with write access, and that'll tell you that you've hit a system where you have local admin.
And so let's take a minute to talk about local local admin access. This is difficult, but more often than not, we find that our clients are actually using this accidentally. It was not a situation where they wanted everyone to have local admin. It wasn't a situation where they needed it. It was merely a situation where they forgot, where they set it up once and turned it down. And so this is where actually doing that review, there's a whole lot of tools you can get to just do groups. You can obviously, we listed a few that'll pull the shares. You can filter on admin dollar like we are here. It's a good review. It's something that you can do probably once on your network. It's going to take a while if you've got a large network, but you can do it. If you want to get more granular, you can also use tools like DumpSec, Exporter Pro, and others. Nessus will do it. That will actually pull the group membership on every system, and then you can do a review as well. It's a couple hours. I know that's a couple hours most of us probably don't have, but to be honest, keeping people from having local admin is one of the, I'd say, 3 top things we could recommend to keep, at least keep your pen testers frustrated, and we're the people you want pissed off.
So the next demo here is the recursion feature. So you'll see we've added, same thing as before, password, username, but we've added this R flag. We're going to have it go 10 levels deep. So it will recurse down any shares that are available for 10 levels. And we're only going to run it against one host. So there's a third way you can provide host, but you can provide a file that's one IP or host name per line. You can provide just one target, so just the host name or IP of a system you want to look at, and it'll go on everything in that system. So that's what we'll do here. We'll let that run. And then the last one you'll see in a second is you can actually limit it to a share, to 10 folders deep in a share. You can give it the full path of where you want to go, and it will actually go and do recursion against those. So you'll see there 1,300 objects it found recursing. And we will open that guy up.
So while he's doing that, the last mitigant we wanted to talk about is admin password reuse. So I would put this again in my top 3. And when clients have, basically, you're deploying from an image or you have it set in group policy preferences where you're setting the local admin password. So that means if I take over one workstation, I have effectively taken over them all, which is bad. Ultimately, all of our networks are getting broken into every day. It's kind of at the point now where we have to just accept that. So it's our goal to contain people down. One of the first lines of defense you can do on that is preventing them from getting access to other workstations. So even if your users are running as regular users, you have UAC set to 4 and everything's perfect, I can still, hopefully, get access to the local admin hash or the local admin credentials. So then, from there, even though you've prevented your regular users from doing things, now the attacker can get access to every workstation. The optimal solution here is to disable the account. But that gets difficult unless you're going to be re-imaging systems. Because if they fall off the domain, well, you're kind of screwed. You're not going to get it back. So there are a few other things you can do. One of the other great ones is to prevent that account from logging on over the network. That way you've got it at the local console if a system falls off the domain, but you've prevented an attacker from reusing it over the network. It works really well. Sometimes you can't do that. Some people haven't been able to get it to work. Some, networks are very complex beasts. So the next best option is to start to group that. Have a password for admins, have a password for IT, have a password for HR, have a password for accounting, so that at least you've contained your access to only the access of the information they already had. If you really want to get crazy, Microsoft, there's actually some PowerShell scripts that you can get that they've put out that will actually set every password on every system in your entire domain to a random value.
Yep, they released it as part of when they pushed that update to quote-unquote kill past the hash. And as part of that, the GPP update that disables the ability to store passwords in group policy and push them to workstations, they actually provided a PowerShell script that will go through, and every Windows workstation you have an AD, it will run against it, set the local password to something random, and dump all that to a CSV for you that you can then throw in KeePass or some encrypted store. And if you have to get to it, have to log in, there it is. But typically, probably not going to need it that often, so it's fine that it's something random. So you'll see here, the CSV, we have directories, files, file shares, the permissions for each of these, who has permissions, same thing, same format for each one. It's just in this one, that object file actually starts to give us folders and directories 10 levels deep. All right, and so our last demo here, you will see, so we're going to give it a specific path. So If you had looked through the results, if I had let you look through the results that we had before, you'll see there's this folder called A Smith, looks like a user directory. I want to know everything that this user has in their user directory, so we're going to run 100 levels of recursion against it and pull everything in just this share. Don't want to do it against everything. This has bitten me before where there's a file server and I want to go really deep on one share, but they also have 10 other shares that are just massive, and it'll just never finish if it has to run against each of these. So you can specify as specific as you want to be. Okay, so we pull that there, and you notice that when you do a specific path, you do have to provide SMB://, which is pretty standard in Samba, but when you're getting that specific, you have to add that. We'll pull up.
No, let's not worry about that.
No? Okay.
Yeah, we got 5 minutes.
Okay. So by the numbers. So right now, this is some of the numbers we pulled with the current version, just to see how fast it runs. It takes about 6 seconds for a standard host, and that includes Samba warming up, the tool warming up, it giving you a little bit of a pause so that if you type the password wrong, you can Control-C before you lock everything out. One host with some recursion for about 6,200 objects takes about 3 minutes, 3.5 minutes. This isn't quite as fast as we'd like it to be, and we'll talk about some ways we're going to try to make it faster, but it's still, from what we were doing, it's much quicker. And finally, a small network with some very limited WAN links we ran this against, so kind of a typical network for us where you have remote locations that just have really shoddy connectivity. Took about 13 minutes, 14 minutes here to do about 165 Windows hosts, but we have used this in networks, as large as 6,000, 7,000 workstation servers. So it'll keep running and going, and just sometimes it might take a little bit.
Okay. So as far as challenges, Samba's a big beast. There's a lot of stuff to it. More importantly, there's actually a patch that we're having to issue to Samba itself. The reason being, if you try and do pass the hash, Samba supports it, but there is one function where you try to pull the extended attributes. And this is where DACLs are, that starts treating the hash as a password again and locks out accounts. So not good. Also, it's written in C. Neither of us have written C in a long time, so it's terrible. So if anybody has any questions, we will be around. Also, if anybody here has written RPC code for Samba, we'd really like to buy you a beer. So we have some questions for some other tools we want to write. So here's the contact info. Thanks, everybody.